in, for example, baseball for some of your students, right? So to calculate a batting average, we take the number of hits they get and divide it by the number of at-bats they had. That's their batting average. I always think it's interesting to see the batting average of Major League Baseball players is usually no higher than 3.300, right? Sometimes it's a little bit higher, but that means they're only getting about a third of the times at bat are they getting a hit. So that makes me feel pretty good about whenever I'm not successful at something. Even the pros don't get it right every time, only about a third of the time.
Right.
Yeah, there are both simple and compound events. A simple event is when there's only one outcome. So for example, if you're rolling a die and you see what number you get, that's a simple outcome. But if there's two or more outcomes, it's a compound event. So if I say I'm going to roll a die and draw a card, right? Or roll a die and toss a coin, that's a compound event. To find the probability of a simple event, you just take the desired outcome and divide it by the total possible outcome. So if we want to know what's the probability of getting heads or tails, well, if we want heads, that's one outcome, right? And there's only two possible outcomes. So it's 1 out of 2. But for a compound event, we multiply the probability. So if we want to know the probability of rolling a 6 on a die and landing on heads, we're going to multiply those two probabilities. So we know there's 6 sides on a die. So the probability of getting a 6 is 1 out of 6. The probability of landing on heads, we already said, is 1 out of 2. Then we're going to multiply those and we get 1/12, which is 0.08333. Probability is expressed in a decimal, usually. So that's why I have it as a decimal. Sample spaces. For this, you can draw it out, and that makes it easy to see. So for simple events, like heads or tails, it's very simple. There's only 2. But if we're doing compound events, it gets trickier, right? So here's the probability of rolling a 6 and landing on a heads. Well, we could get a 1 and heads, 2 and heads, 3 and heads, and so on. Or we could get a 1 and a tails, 2 and a tails, 3 and a tails, and so on. And then we can see there's 12 possible outcomes, right? So in the previous screen, we saw there were 1 out of 12, right? 6 times 2 is 12. But here we can see it more easily by drawing out the sample space. And then we could say, okay, what's the probability of getting 1 in a heads? It's 1 out of 12, which is what we did on the previous screen. We could also do it a tree diagram if we want to know what's the probability of rolling a 2 on a die and then drawing a green marble. So we could draw out, here's rolling all of the numbers. And then after we roll the numbers, we draw a marble, blue, yellow, or green. What's the probability of rolling a green? Well, it's 1 out of 18, right? We would count up all of those outcomes, and there's 18. And there's only 1 rolling a 2 and getting a green. Using probability. So probability can be useful in the real world if we're trying to plan something. Like maybe we're planning a wedding and we want to know if we can do it outside. What's the chances of it raining that day, right? So we can look at historical data and make a prediction. So maybe in the past it's rained 5% of the days. Well, then we know we've got a pretty good chance of having clear weather, right? So the probability of that would be 0.05. There's something called theoretical probability and experimental probability. Theoretical is how it works in the perfect world. So we know that if we were supposed to roll a die, not a die, toss a coin 100 times, theoretically we should get 50 heads and 50 tails. But we both know if we do it 100 times, we might get 49 heads and 51 tails. Or we might get 45 heads and 55 tails, right? Because our experimental probability is how it works in the real world. But the more repetitions you do, the closer your experimental probability gets to your perfect world theoretical probability. And they ask questions like that all the time about how can we get the experimental probability closer to theoretical by doing more experiments, more repetitions. All right, solving probability problems. These get pretty tricky. So what's the probability, like let's say you're making a special birthday cake, right? And the mom puts coconut on 1/3, chocolate sprinkles on 1/3, and multicolored sprinkles on 1/3. The inner circle has filling, but the outer circle does not. What is the probability of the student placing the birthday candle on the part of the cake that has the filling and the coconut? So it'd have to be in this inner circle and in 1/3 of it, right? So we have to find the probability of this little tiny section here. Let me put of this section right here. That's what we're looking for, right? So let's see how to do that. First, we're going to find the area of the two circles. The area of the large circle is pi r squared, and the larger r is 6. So pi times 36, which is 113.097. You have to memorize that formula. Now we need to find the probability of the smaller circle, pi times 2 squared, because this is the smaller radius, right? Which is 12.566, right? The area of the largest circle, the entire cake, is 113.097. The inner circle is the only part with filling, which is 12.566. Okay? The probability of the candle being placed in the part with filling, you have to divide the area of the smaller circle by the area of the larger circle. Right? So we're going to divide those two numbers. Right? We could also do it like this. Okay, but this is the next step, not could do it also. So that's 0.111. But we know that only 1/3 of the coconut, only 1/3 of it has coconut, right? So we have to multiply that by 1/3, and then we get 0.037. So see how first we find the probability, the area of the large circle, then the small circle, then we divide those two, and then we multiply by 1/3 because only 1/3 of it had the coconut on it.
So I have a question. So you were saying that there's a formula that you have to remember.
Yes, area equals pi r squared.
Me and math is not good. So is there a possible tip or a trick, to kind of remember when it comes down to probability, or if it comes, to a probability question, how can you kind of know how to kind of figure it out or decipher from one question to another by being multiple choice? Do that make sense?
You just have to do lots of practice like anything else. There's no big shortcuts, just lots of practice. So like getting a really good course or book and doing all of it and doing release star tests is also helpful. But you just have to memorize the formulas and then be able to apply them. So it just takes lots of practice. But the release star test is a great way to get some extra practice. If you just Google released star test and it has the answers, right?
Okay.
So you can do that, and that's free. You can get my course and you can see I explain things it's still not easy, right? But I make it as easy as it can be. I'm not explaining things in a math professor kind of way. So you could get my course and maybe find it easier like that. Summary statistics, right? So if we want to, summary statistics give a quick description of the data, like the mean, median, mode, range, and standard deviation. Luckily, you don't have to know much standard deviation on that. But by quickly seeing the mean, median, and mode, we can see that, and the range, we can see the lowest number for a grade was a 28. The highest was a 98. The most number of students that got the same score was 87, right? Several people got 87. The number in the middle was 82, and the overall average was 86, right? So if we know that, we know almost everybody got B's, right? Because the mean, median, and mode are all in the 80s. So not very many people got really low scores, and not a lot of people got really high A's either. It was all mostly in between 82 and 87. Statistical experiments. This is what we were talking about earlier, repeating the data to get accurate events, right? So let's say we're going to do a fall festival and we want to predict the weather and then determine what we're going to do according to the weather, right? So we collected data from the last 5 years, the dates of the events, the weather, the number of people that attended, right? How can the students use that data to choose what type of activities to host? So if we can look right here, when it's sunny, they make more money from games and rides, right? And not as much from food. But when it's rainy or cloudy, they make more money from food and less on rides and games. So then they can look at the data and say, well, if it's supposed to be rainy, we should have more food. And if it's going to be sunny, we're going to do more games. So see how we can use it in the real world to make predictions on owning a business, right? All right. So you could bring a large dartboard to class and throw darts, right? And they can do probability like that. What's the probability of getting the bullseye, right? So the area of the whole board is 100, 10 times 10, 100 square inches. The measurement of each of the radius is listed here. The green circle is 4, the purple is 3.5, and so on. The red is 1. What's the probability the dart will land somewhere within the green circle, right? So the biggest circle, the radius is 4. I'm sorry, the radius is 4, right? So first we'll calculate the area of the total space, which we said was 100 square inches, 10 times 10. Now we'll calculate the area of the large circle, which is pi r squared. So we have pi times 4 squared, and we get 50.266 square inches. So that's the number of square inches in this big circle, and basically what we call the dartboard, not the exterior part where you don't want to land, right? Then we're just going to divide that. 50.26 divided by 100 inches squared, and you get 0.5. So it's about a 50% chance of it landing on that circle. So there's a good chance you're not going to get on the dartboard. You're going to get on the empty space in the frame. And then a normal distribution looks kind of like this, right? Where there's about the same number in the top and about the same in the bottom. They call that a bell curve, where exactly 50% of the data is above the average and 50% is below the average. So that's probability and statistics. Let's do a couple of quick questions and then we'll be done. A fifth grade class is studying probability. The teacher breaks them up into small groups. Each group is to roll a die 50 times and record how many times the 1, 2, 3, 4, 5, and 6 is rolled. Next, they make a frequency chart and determine the experimental probability of rolling each number. Then as a class, they share their results on the smartboard. Students know that the theoretical probability of rolling each number is 1 out of 6, but the probability the groups found from their experiment varied greatly from 1 out of 6. Each group had different probabilities for each of the numbers. What is the best explanation for this discrepancy? The students likely recorded their answers incorrectly, resulting in faulty data. Maybe. The students must have incorrectly calculated the experimental probability. Since the number of rolls was limited, 50, the probability is based only on that. If the student rolls the die more times, the probability of rolling each number would be closer to 1/6. This is what I was talking about, where if we do more repetitions, we're going to get a better, more accurate result. So C is the best answer so far. Students should try the experiment again, this time rolling the die 10 times, since a smaller sample will result in the experimental probability being closer to the theoretical. We don't want a smaller sample size. We always want a bigger sample size. So that's correct. What type of graph, table, or chart would be easiest to quickly determine the mean, median, and mode? So you might remember we looked at this earlier, and it's a stem and leaf plot, right? That was the one that shows the numbers with the tens unit or the hundreds unit on the left, and then the other numbers on the right. So do you already have my course, Shakimia?
No, I had text you. We was texting back and forward at one time, and then I found your Facebook. I found your Facebook page, and then I just went through a couple of your posts, and I was trying to figure out your the course and how your how it go and what it because I was originally asking you about one-on-one tutoring because I have to take the test. I'm going to take a spring break the week of my spring break.
So you have about a month, I guess, right? About a month to study?
Yeah, about a month. So I'm really trying to get it all in because I really want to pass it my first
try.
My first go around. I want to pass it my
Good.
first.
Well, I put the link in the chat box for my course, and since you're going to take it soon, you could just sign up for 1 month and cancel right away, then it won't keep billing you, or you just text me and I'll cancel for you, because I certainly don't want you to get billed for a second month if you're done. So you can do that. And what sets me apart, like there's lots of big companies that have great programs. I've bought some of them, and I have to say most of them are really good, but they get overwhelming and they include information you don't need to know. And I don't
Yeah,
think
because like I did, like I'm with I teach, so I had to do the passage preparation, but I had to. So I'm not gonna even lie, I didn't even go through the modules. I just took the test as many times as I possibly could and make an 85.
yeah.
And
Some of those programs, they're just too boring or too overwhelming, but I think for
yes,
mine, it's pretty simple. You can get through it pretty quickly, like in hours, you can get through it. But maybe to really understand it, you do it 2 or 3 times, right? But still, it's going to be way faster than some of the programs I've bought that I'm like, how do you, it's good stuff, like I said, but how do you ever get through all of that? And a lot of it is a waste of your time, because I think that what they do is they hire people with a PhD or a master's degree in that field, which is good. They're experts, right? But they're putting all of this stuff on there that's like on other tests, the Florida test, the California test. All we need is the Texas test, and that's all I do.
so the core subject EC-6 391, that one,
Yes,
that has
that's the link for.
all the subjects.
Yes, it's got all the subjects for $39.99 a month. So you could sign up and cancel right away, and you'll
Because
have
I
1 month.
also, when I said that I went through your thing, I had went through, and I thought I signed up to do. Uh, I think you had like so much off for your tutoring session, or so much off for your course.
I think that you might be thinking of Tutoring Easy usually does that. I don't usually do that.
Oh, I thought I saw that on one of your posts, where you was doing, you did a
No, sometimes my contractor will post a coupon code, but that's about it. I don't really do discounts off the tutoring or anything. But I think you'll find that my course has so many good videos, you might not even need tutoring. That's what people tell me. It's like getting tutoring built in.
okay.
So yeah, that's the link in the chat box, but I can also email it to you. I've got to run to get ready for my next session, but thank you so much, and I hope you learned a lot.
I did. Okay,
Oh,
yes. Can you
good.
please email that to me?
Thank you, Shakimia. Take care. Bye.
You too. Bye bye.